The general graph search is a way of stepping through a graph where it's unclear, where it is clear how to step through a tree. It's in general unclear to step through a graph because there's multiple different ways to step. And we have to be able to handle cyclical dependencies. So the general graph search algorithm is going to take in a starting vertex, someplace to start from, and it's going to take in a data structure. This data structure can be a stack or a queue or a priority queue. And the priority queue can also have different comparators, and depending on what data structure we pass in, it will have the graph search will have different behaviors, and different data structures are used in different cases. But the very first thing we're going to do is we're going to make a visited list because we don't want to visit the same node multiple times or same vertex. So we're going to make an empty list and call it visited, and we're going to take the start node and add it to the data structure. Now this is where the general graph search starts, is while the data structure is not empty. So right now it only has the starting vertex in it. We're going to pop out the very first thing of our data structure, or the next element, or next item, and that's going to be our current vertex. If our current vertex has not been visited yet, then we're going to add it to our visited list, and then we're going to have some method to evaluate current. So maybe if we're searching for a goal, or if we're planning paths, and we may have to send some data back in some way. But evaluate current is where you do the actual work in the search, if you have to do any work. And then for each of the neighbors of the current node, we're going to add that neighbor to the data structure. Okay. So when we loop back, now the data structure has all of the neighbors of the start node inside of it. And we can pop out the first neighbor, and if that neighbor is not in visited list, then we do the same thing. You can see that given different data structures, maybe with a queue or a stack, we'll evaluate stuff close to us first, or evaluate stuff far away from us first.